Hello everyone. In this module, we are going to learn logarithmic axis and following are the topics that we are going to discuss. Firstly, we will learn about the logarithmic axis. After that, we will see how we represent it. Then we will see some important points regarding this. After that, we will also learn how it works and we will also see the cases in which we use the log scale. And in last, we will discuss how we plot the logarithmic axis in Matplotlib. So Matplotlib provides us an feature to change the axis scale to logarithmic, and in algebra log stand for the logarithmic. The log is another way of defining exponential equations like y equals to x raised to power 5, or in simple words we can say that log help us to determine how many times one number must be multiplied to get another number. So now we will see how we represent a log. Log are represented symbolically by the equation log b, then in braces we pass by equals to x. In general we pronounce it as log base b of y is x, and it is the same as the exponential equation y equals to b raised to power x, where b stands for the base number and x stands for the exponent. So now we will discuss some important points regarding this. The base b of any log must be bigger than the 0 and can't equal to 1. And the another point is sometimes there is no base written. In these cases, assume the base equals to 10. So we can say that by default the base value is 10. So now we will see how log works. For example, we have an equation 5 raised to power 3 equals to 125. Now in terms of log, it is represented as log. In base power we write 5, then in braces we pass 125 equals to 3. So the log is the exponent, we know that. So here the log is 3 as we write as 5 raised to power 3. And the equation means that when the base 5 is raised to exponent 3, the result will be equal to 125. So now we will see the cases in which we use the log scale. So in the days before calculators, the logarithms were invented to help in solving the long equations. They are now utilized to solve the compound interest also. It is also used in the cases of population expansion. It is also used to calculate the radioactivity decay. You can also use to show balance for the customer for a specific bank, and it is also used in the time series cases. So now we will learn how we can plot these logarithmic axes in Matplotlib. We have the following functions: x scale, y scale, semi-log x, semi-log y, and log. So let's discuss each function in detail one by one. So the first function is x scale function. We use the x scale function of the pyplot module to set the scaling of the x-axis. When we pass log or simlog scale in the function, the axis is represented as a logarithmic scale. And the syntax of the function is matplotlib.pyplot.xscale, and in parentheses we pass value and keyword arguments. So the another function is y-scale function. We use the y-scale function of the pyplot module to set the scaling of the y-axis. When we pass log and simlog scale in this function, the axis is represented as a logarithmic scale. And the syntax for this function is matplotlib.pyplot.yscale, and in braces again we pass value and keyword arguments. Now we will discuss its parameters. The first parameter is value. To set axis scale, we use this parameter, and if we pass value as a log, only positive numbers are represented, and if we pass simlog, it used for both positive and negative values, and the keyword arguments are passed to customize the scale property. So now we will see an example related to x scale and y scale function both. So here is the code related to x scale function. So firstly I import the matplotlib.pyplot as plt library. After that I define the data coordinates. For this I take two variables x and y. Then I plot a line chart between x and y. So I pass x and y as an argument to the plot function, and I also format the line style, line color and marker style. So I set it color to red, line style to dashed and marker style to circle. Then I want to convert the x-axis scale to logarithmic. For this I call the xscale function and I pass log as a value to it. Then I add labels to the plot. For this I call xlabel and the ylabel function. So xlabel function add label at x-axis and ylabel function add label at y-axis. X-axis represent x-axis as I pass x-axis as a text, and ylabel represent the y-axis as I pass y-axis as a text. And I also change the font size of the both the text to 20 by using the font size parameter. I also add a title to the plot to get to know what this plot is. So I call the title function, and as a title I pass log plot using xscale function, and I set its font size to 25, and I also change its font name to brush script empty, and in last I call the show function to display the plot. Now I execute this code and here is the output. You can see that here the x-axis changed to the log scale and y-axis remaining to the default scale. So now we will see an example related to y-scale function. So firstly I import matplotlib.pyplot library as PLT as we are working on a matplotlib library. Then I again define data coordinate x and y. Then I plot a line between x and y, so I call a plot function and pass x and y as an argument to it. And I change the color of the line to green, style of the line to dash, and marker style to circle. Now I want to convert the y scale to logarithmic. So for this I call a y scale function and I pass log as a value. So next I add labels at the axis. For this I call xlabel function and the ylabel function to add labels at x-axis and y-axis respectively. So I pass x-axis as a text to the xlabel function and y-axis as a text to the ylabel function. And I also change the font size of the label and set it to the 20. Then I call the title function to add a title to the plot to get to know what this plot represents. So as a title I pass log plot using a y-scale function, and I also set its size to 25 and I change its font name to brush script empty, and then I call the show function to display the plot. Now I execute it and here you can see that this time it changed the y-axis to the log axis, not the x-axis. So we can conclude that if we use the xscale function, it converts the x-axis to the log scale, and if we use the y-scale function, it converts the y-axis to the log scale. Now we will see one more function which is semi-log x function. We use the semi-log x function of the pyplot module to set the log scaling on the x-axis, and the default base of the logarithmic is a 10 in this case, and the syntax of this function is matplotlib.pyplot.semilogx, and we pass base, sub and non-positive and keyword argument as a argument to this function. Next function is semilog y function. We use the semilog y function of the pyplot module to set the log scaling on the y-axis, and the syntax of this function is matplotlib.pyplot.semilog and I pass base, sub, non-positive and keyword argument as a argument to this, and it also has a default base value 10. So now we will discuss these parameters in detail. The first parameter is a base. It take value as a float and it is a base of a x and y algorithm. The next one is sub s. It take value as an array, the location of the minor x ticks and the y ticks. And the next one is non-positive. It take value as a mask or a cliff. It is a non-positive value in x and y, and it can marked as a invalid or a clipped to a very small positive number. So now we will see an example related to semilog x and semilog y function. And here is the code related to semilog x function. So firstly I import the necessary libraries which I required. The first one is Matplotlib pyplot as PLT. The next is NumPy as NP. Then I define data coordinate x and y, and for defining x I use a arrange function of a NumPy module, and for defining y I take x raised to power 2 plus 5. The next I call the scatter function as I want to plot a scatter graph, and I pass x and y as an argument to it. Then I want to convert the x-axis to the log. So for this I call the semilog x function, and I also want to change the base of the log from 10 to 2. So I pass base as a parameter and set its value to 2. Next I call the x label and the y label function, and I add labels to the axis x and y respectively, and I also change the font size to the 20. Then I add a title to the plot by calling the title function, and in last I call the show function to display the graph. Now I execute this code, and here you can see that it converts the x-axis to the log scale and it takes 2 as a base value. Now we will see an example related to semilog y function, and here is the code. So firstly I import the matplotlib.pyplot library as PLT, then I define data coordinates and I take year and profit as a variable. Then I call the scatter function as I want to plot a scatter graph between year and profit. Then I want to convert the y-axis to the log scale, so I call the semilog y function, and I want base value as a 10. I call this function without any argument. Then I call the x label and the y label function as I want to add labels at the x-axis and the y-axis. So we know that the x-axis represent the year and the y-axis represent the profit. Then I call the title function to add a title to the plot, and in last I call the show function to display the plot. Now I execute this code, and here you can see that the y-axis changed to the log form, but the base remains to 10 as I don't pass any base argument to it. So with this we conclude that if we want to change the x-axis scale to the log 1, we can also use the semi-log x function, and if we want to convert the scale of a y-axis to the log 1, we can also use the semilog y function. Now we will see one more function which is log function. We use the log function of the pyplot module to construct a log scaling on the both x and y axis, and the syntax of this function is matplotlib.pyplot.loglog, and in parentheses I pass base, subbase and non-positive argument and also the keyword argument. Now we will see the parameter in details. The first is base. It take value as a float and it is used to set the base of the x and y logarithm. The next one is subbase. It take value as an array and it is used to set the sequence of a location on the minor x and minor y ticks. The last one is a non-positive. It take value as a mask and a clip, and it is non-positive value in x and y, and it is used to mask as a invalid or a clip to the very small positive number. So now we will see an example related to log function, and here is the code related to log function. So firstly I import the necessary libraries. The first one is matplotlib.pyplot as PLT. The next one is numpy as np. Then I define data coordinates, and for defining x I use the range function of the numpy module, and for defining y I use the exp function of a numpy module, which means exponent function. Then I want to convert both axes to the logarithmic, so I call the log function and I pass x and y both as a argument to it, and I also want to change the base value from 10 to 4, so I pass base parameter to the log function and set its value to 4. Then I call the x label and the y label function as I want to add labels on the axis of the plot. Then I call the title function to add a title to the plot, and in last I call the show function to display the graph. From here you can see that I pass x and y data coordinate to the log function instead of creating any line chart or a scatter plot. So you can pass x and y data coordinate to log function. It can plot a line chart by default. If you want to plot another chart like scatter or a bar, you have to call the specific function. Otherwise, you can pass x and y value to the function itself. Now I execute this code, and here you can see that it converts the x-axis and the y-axis to both logarithmic axes, and it takes the base value as a 4. So x-axis like 4 raised to power minus 3, 4 raised to power minus 4, and so on. And the y-axis as a 4 raised to power 0, 4 raised to power 1, like this. So with this, we have learned logarithmic axis in Matplotlib, and in the next module, we will learn sharing of the axis.